This is a review packet for the quiz for 2.4 to 2.8 in your algebra textbook. Okay, so starting with 2.4, number 1, which expression is not equal to the opposite of negative 2x plus 5? That's how we're going to read this. Instead of negative 2x plus 5, we're going to say the opposite of. Either way is technically fine, but that's what they're saying here. What's the opposite of this? So we distribute that negative, and it's going to make this negative positive, and it's going to make this positive negative. So it's going to match letter A. That one is equal to. If we slide over to letter C, there's a negative 5 and a positive 2. That one's good. And over here, we've got the negative 5, and two negatives here make this a positive 2. So this one is also good. Letter B would be the answer here because it does not have the minus 5. Okay, number 3. Basically, we just want to count up these negatives. It's negative, 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 negative. Every two negatives will cancel each other. So these two negatives make a positive. These two negatives make a positive. And that's going to leave you with just one negative here. And so your final answer is just negative m. Distributing the negative goes to the 2. It's negative 2p. Goes to the 1. That's minus 1. Distribute the negative. It's negative 3z. Distribute the negative. That's minus 2. We must distribute this negative before we start to combine like terms. So this is going to be a minus k squared, and it's also going to be a minus 5, and that's where people mess up. Bring this down. Combining these now, because they are like terms, it's the same variable with the same power, so it's a 7 minus a 1. This is a 6k squared. Nothing happens with the variable when we're just combining like terms. Minus 5. Same idea here. We're going to distribute, so negative 2x and negative 6. Cannot forget the negative 6. Like terms are your x's, those combine to make 3x, and we still have minus 6. Okay, number 10. You see the parentheses. This is what has to get distributed as it butts up to it. Now, dividing by 4 is the same as multiplying by 1/4. So we got to bring the negative, but in terms of the numbers themselves, you're dividing by the 4 when you take 1/4. That's all we're doing here. So you can plug it in your calculator and multiply by 1/4, but all we're doing is dividing by 4, and you'll notice both of these terms divide nicely by 4, so that's on purpose. So the 2r comes down. A negative times a positive is a negative. 8 divided by 4 is 2r. So you can already see these are going to cancel. And then when this gets distributed, first of all, it's a negative. Negative times a positive. And 16 divided by 4 is 4. So these like terms combine, but they make 0 because it's 2 minus 2. So all you're left with is negative 4. All right, number 11, before you can combine like terms, we must go ahead and distribute this negative. So it's negative 2xy, but a negative and a negative is a positive 1. Now you can combine. So the big mistake is people don't make this a positive 1 because the negative gets distributed. So I have these xy's here, and these xy's are going to combine, and that's going to be a 4xy. And I have a minus 4, and I have a minus 1, and that's a minus 5. Oop. See, and easy mistake to make. I said minus 4 and minus 1, right? It's a plus 1. So when I combine negative 4 and positive 1, that is negative 3. So the mistake there. All right, again, looking at all these negatives, every two negatives are going to cancel. Oh, and I'm going a little too fast here. I almost missed the fact that this squared is not on the k, it's on the outside. So let's go back for a second. We have a negative k in parentheses squared. That means it's negative k times negative k. So when that happens, what does that become? A negative times a negative is a positive k. So I think now that I've done this, I'm going to rewrite it so I can show you what's happening without making a mess. So this piece in here, we just completed. It's negative k times negative k squared. That becomes positive k. So this is positive k. And now I've got these three negatives still sitting out front. So these two negatives here will cancel each other out and make a positive, but this one negative out front will stay, making this a negative k squared. And I didn't carry that squared through here, and that's my mistake. I was focused on the negatives, but a k times a k is a k squared. Okay, number 14. Same idea, just dealing with some negatives. With some decimals. Don't let that bother you. So it's negative 0.7t, and a negative is a positive 2.1. So we're going to combine that with everything over here. If you want to bring it down, you can. And so the t's are going to go together, and that's a positive 5 minus a 0.7. That's negative 0.2t. And this is a negative 1 plus 2.1. Feel free, just plug it in your calculator, and that is positive 1.1. Okay, 15, we must distribute this first. Okay, so we've got a negative times a positive, so this will be negative. 0.2 times 0.5 is 0.1 y. And a negative times a negative is a positive. 0.2 times 15 is 3. So I've got 100.2y plus 0.1, and then the rest of this. So we're going to combine like terms. I've got 100.2y minus 0.1. That's 100.1y. And a 0.1 plus 3 is a 3.1. Okay, 16, distribute the negative. So it's negative 6j minus 12. Bring everything down. Combining 4 minus 6 is negative 2j, and 1 minus 12 is negative 11. Okay, multiplying. First of all, I have a negative times a negative. That's a positive. Times another positive. So my answer is going to be positive. These negatives will cancel themselves out. Multiplying coefficients. 5 times 1 times 2, that's 10. F times F times F, that's F to the third. 18, this is a negative times a negative. So it's positive. 5 times a 1, that's 5. P times P squared. Remember, this is a P to the first. And when you multiply, you add the exponents. This is P to the third power. Right here, we can combine everything over 3, but when we do so, it's this quantity minus this quantity. So we got to do it with parentheses. So it's minusing like this. So just like all of these ones we just practiced, we're going to have to distribute that negative. So I'm going to go ahead and do that right here. So the 2 plus d comes over, minus 2, negative gets distributed, that's a plus d. So 2 minus 2, combining, those are 0. And d plus d is 2d, and all of that's over 3, and that's fully simplified. Okay, to the back on 2.5. We're going to fill in the table and see if these are equivalent based on that. So let's start with the 0. We plug in 0. We're going to multiply. We're going to square it. It's going to be negative, but there's no negative 0. So it's 0 minus 4. That's negative 4. Put the 0 in. Exponent, multiply, negative, doesn't matter. It's still 0 minus 4. That's negative 4. Let's try the 1. 2 times 1 is 2. That's squared. Before this negative comes in, it's squared. So 2 squared is 4. So this is negative 4. The negative goes with it. Negative 4 minus 4. That's negative 8. How about right here? 1 squared. You got to do exponents first now because there's no parentheses. 1 squared is just 1 times negative 2 is negative 2. So this is negative 2 times 4. And this is going to be negative 6. And you would run all of this through. The key here is this is in parentheses, so you have to multiply first, then raise to the exponent. Your answer becomes negative, then minus 4. Over here, there's no parentheses, so you are going to have to do the exponent first, whatever x is square, and then times it by negative 2, then minus 4. So a little bit different order there because of the parentheses. So you can already see these are not going to be equivalent. So your answer here is no, and the answer key will fill you in on these other ones. You should have run the numbers with your calculator, but this is what they come out to. The important part is right away, as soon as you see you've got 2 different numbers, you should go to another line and make sure that you didn't just make a mistake and get 2 different numbers, but as soon as you start to see a pattern that there's different ones, we know they're not equivalent. Okay, number 10, consider a hexagon. Now, you might have had to look that up. Hexagon, how many sides is that? So that's a 5-sided shape. No, that's a pentagon, I'm sorry. Hexagon is a 6-sided shape. And so we want to write 2 equivalent expressions for the perimeter. So you'd have 6 sides. So you didn't have to know exactly what this looks like, but a hexagon looks like this. 6 sides, that's what you need to know. Every single one of those sides is 5s plus 3. So the same, they're all equal to each other. We want to write 2 equivalent expressions for the perimeter. Perimeter means adding up all of your sides. Okay, and what we're going to do is we're going to write one of them as adding them all up, so 6 of them. So you're going to have 5s plus 3 plus 5s plus 3 plus 5s plus 3 6 times. That's the first expression, and that's the long way, but that shows you're adding up all of your sides, 1, 2, 3, 4, 5, 6, because all of these are 5s plus 3. You could write them all the way around. But instead of adding it 6 times, you could just multiply it by 6. And it looks like this. And it says verify that these are equivalent by using a table, graph, or simplifying. So let's go with simplifying. I can distribute here, and I'm going to get 30s plus 18. That's simplified. And if I added this up, 5, 5, 5, 5, 5, 5 is 30. 3, 3, 3, 3, 3, 3 is 18. I've proven they both simplify to the same thing, so they are equivalent. Okay, consider a rectangle. Length is 6x minus 3, width is 9x plus 4, and it really doesn't matter which one you call length and width. If it's a rectangle, though, I know the other side is also 6x minus 3, and I know this side is 9x plus 4. Opposite sides of a rectangle are equal. So when I go to add this all up, I'm adding up 6x minus 3 twice, because there's two sides that are 6x minus 3. And then I'm adding 9x plus 4 plus twice. So what's another way to write that? Instead of writing this twice, it'd be 2 times 6x minus 3 plus, instead of writing this twice, 2 times 9x plus 4. Okay, and then if you want to prove that these are equivalent, you're going to distribute. This is going to take 2 quick steps here. So I'm going to get 12x, and I'm going to get minus 6 plus 18x plus 6. Not plus 6, plus 8. All right, 2 times 4 is 8. I knew something was off. Okay, and so when I combine all my like terms here, 12x plus 18x is 30x, negative 6 plus 8 is positive 2. So I have 30x plus 2, and if I add these all up, 6 and 6 and 9 and 9, that is 30. Negative 3, that's negative 6, plus a 4, and a 4 will get you a positive 2. They simplify to the same thing, meaning these two expressions are equivalent. All right, we're going to simplify these two expressions to see if they are equivalent. So I have 3x to the 4th times x minus 1. Complicated looking thing. So let's start there, and then we'll get to the second one. So just looking at this, let's distribute. X times x, you add the exponents. So this is a 4 and a 1, this is 3x to the 5th. Minus, times 1 is just the same thing, so 3x to the 4th. Minus, distribute this now. So this is not actually a minus, going a little fast here. A negative times a negative is a positive, so I do need to write plus. Add your exponents. It's a 1 times a 3, so that's a 3. X to the 1st, x to the 3rd, that's x to the 4th. Now also distributed here, that's a negative and a negative, that's a positive. It's a 1 times a 4, the 4 is going to stay and the x tags along. Minus 3x to the 5th. Okay, you can lose yourself in there, so you got to be careful distributing your negatives, keeping track of everything. Now you're going to combine like terms. Now I have 3x to the 5th. I can only combine the same exponents. So here's my other x to the 5th. Well, it's a positive 3 and a negative 3, so those are going to create a 0 and cancel out. Look at the x to the 4ths. X to the 4th, x to the 4th. It's negative 3 and positive 3. That completely goes away, and all I'm left with is 4x. So this first one simplifies to 4x. So all I have to do now is test my other one and see if that simplifies to 4x. Now this was a little confusing. I don't like the way they wrote the question, that this continues on to the next line. That's kind of goofy. But this is one long expression if you were confused. So you can see from here it goes down to the plus and this. Okay, so distributing, this is going to be 3x to the 5th, adding your exponents, times 2, that's a minus 6x squared. When you multiply something like this with an x times a whole number, just the coefficient is going to be affected, the x squared tags along. Plus 2x squared minus 3x to the 5th. So combining like terms, 3x to the 5th and minus 3x to the 5th will cancel. X squareds will go together. And so this is a negative 6 and a positive 2. That's negative 4x squared. And so this one gave me a 4x, and this one gave me a negative 4x squared. I can say no, they're not equivalent. I've proven it because they do not simplify to the same expression. Okay, number 9, just wanted you to do one of these. Make sure you understand these fact triangles. So we're going to solve this letter A using a fact triangle and then using the property of equality, which means solving it algebraically, basically. So quick fact triangle here. Here's your adding. That goes at the bottom. So you have r and -10, and it doesn't matter which side you put them on. They're going to equal -25. If you're going to solve this using the fact triangle, what you do is you isolate the variable. So you're going to combine the other two together, and they're going to equal your variable. So if I'm reading this fact triangle from top to bottom, since I want these two together, because those are your numbers, it's -25 minus -10 equals r. Now, we've talked about there's 4 facts total, but you want to create the one that isolates your variable. So it's numbers equals r. Then you can just do the math. So -25 minus -10 goes plus plus, and this is -15 equals r. So that's letter A. That's how you use a fact triangle. Now, algebraically, which is what we're going to move to full time here pretty soon, what we want to do is we want to isolate the variable, which means turn this into 0 so it goes away. So in order to do that, this is -10. How do I get -10 to 0? I add 10 to get it there. But the addition property of equality says I can't just add it to one side of the equation and have this still be true, meaning equal on both sides. But as long as I add 10 to both sides of my equal sign, it maintains its equality and both sides are still equal. So a -10 plus 10 is 0, and they go away, and that's what we wanted. So all we have left is r, and -25 plus 10 is -15, and we get the same answer using algebra. All right, down to the bottom here, 13. We're going to go ahead and use our algebra to do this. So here's k. So I want to get this 20 to a 0. So I'm minusing 20. I have to do it on both sides to get rid of it. So this goes away. 5 minus 20 is -15. I still have my equal sign here. This is gone, and I have just k. Once I have k equals a number, I'm done. That's the answer. Okay, here, now this one, I should have crossed this one out. This one's a little complicated. So we're going to have to minus the 1, and then we're also going to have to get rid of this negative. And that's a little bit more than we need to be doing right now. So for now, actually, let's just go ahead and skip that. To me, that's a 2-step, and these are all supposed to be 1-step. So we're going to leave that one alone. We'll come back to those in the next section. Okay, here we want to get p by itself, so I have a -4, which is like a -4. If I want to get rid of it and clear it out, I need to get it to 0. So how do I get -4 to 0? I add 4. -4 plus 4 is 0. Got to do it to both sides to maintain equality. -100 plus 4 is -96. Equal sign comes down. All that's left over here, since this has canceled itself out, is a p. And once I have p equals a number, I'm done. All right, over here, just dealing with your fractions, w is by itself here. I have a plus 3/2, so I'm going to have to minus 3/2 to cancel it out, which means I have to minus 3/2 over here. Let's say you had to do this in your calculator. Just a quick reminder, on these calculators, you hit alpha and x to get your fraction. So green alpha button and then the x button right next to it. So we're going to do 3 over 4, go to the side, minus, and now alpha x 3 over 2, and that's -3/4. That's what's left on the left side. It equals w, and we are good to go. Okay, 17, get u by itself, so get rid of the -7 or -7, so I'm going to add 7 to both sides. This goes away. I now have 0 plus 7 is 7, and u, and there's my answer. Right here, c needs to be isolated, so a -10, we're going to plus 10 to get it to 0, make it go away, but you have to do it on both sides. So c is by itself now because the 10s went away. -10 plus 10 is 0. You didn't do anything wrong. 0 is a number. Okay, add 6 to get rid of it. We're left with 16 equals D, final answer. 20 again is a 2-step. You'd have to minus the 1/4, and then you'd have a negative q, which you'd have to do more with. So again, I should have crossed that one out. We're not doing that one. Same thing here. Let me just show you this one so you can see it once, but this is not going to be something that will be on your quiz. So -5 to get rid of it. So that goes away. -2 minus 5 is -7. But what you're actually left with is the negative g equals -7. And what you need to do is get rid of that negative. So you have options. You can multiply both sides by -1, or you can divide both sides by -1. Either way, the negatives will both drop off. So if I multiply by -1 and multiply by -1, I end up with positive g equals +7, and that's the answer. So I want you to see that. That's where we're going, but that is not on your quiz. This one should have been crossed out as well, so I apologize. We have a minus 10, so we're going to plus 10 and plus 10. This goes away. You have k. Negative 90 plus 10 is negative 80. Okay, additive inverse, that's just the number that when you add it, you get 0. So it's just the opposite, meaning the positive and negative version. So I have negative 5. The additive inverse is 5, because negative 5 plus 5 is 0. Okay, negative 6 plus 6, this is just 0, right? So what's the opposite of 0? It's just 0. What do I add to 0 to get 0? 0. How about e? What do I add to e to get 0? It's the opposite, negative e. What's the opposite of u to the fourth? Negative u to the fourth. Now, what's the opposite of an entire expression? So the opposite, or the additive inverse, is going to look like this, but you want to fully simplify it. So it's the negative version or the opposite of this whole expression. You're going to distribute to get your simplified version, so negative x plus 9. This one you should simplify first. 2 negatives cancel out. The negative stays. So this is really negative 9. So what's the additive inverse of negative 9? It's positive 9. Right here, you want the opposite of negative 2c plus 4. So you have to distribute that negative. So you're going to get positive 2c and you're going to get negative 4. You could just look at it and change the signs on each one as well. This is just a term, so the opposite is the negative version of it. And right here, it's going to be the negative version of it, but you need to think of it like a quantity like this. So we're going to distribute that negative. So you're going to get negative 2, and then you're going to get positive p when you distribute that negative over 4. Now you could split this up into 2 pieces, and because it's 2 over 4, you could simplify to 1/2, but since it's not a whole number, we're just going to leave it like that. All right, last page. Find all the solutions to this equation. So we have 2 different letters here, so meaning we're plugging in potentially 2 different numbers. They're both being multiplied by 4, and when I subtract them, we get 0. So what do I know about these numbers? They have to be the same number. Okay, 4 times something minus 4 times something gave me 0. If this is 2, this is going to have to be 2, so it becomes 8 minus 8. If this is 1, this is going to have to be 1, so it's 4 minus 4 to get 0. So what do I know? I know m has to equal n. Okay, 0 times what number gives me 0? That's any number. Over here, negative 10 times something got me 0. That means w has to be 0. It can't be anything else. Negative 10 times anything else is not going to give me 0. Only 0 makes that true. And over here, 0 times something gives me a number other than 0. There is no solution. There's no number you can plug in there to actually make that happen because 0 times anything is 0. All right, we just did additive inverse. So what's the multiplicative inverse or the reciprocal? This is when we multiply and we get 1. So what do we multiply this by to get 1? We talked about x over 1. The reciprocal, you flip the fraction, is 1 over x because you end up with x over x straight across, which is 1. So we're looking for how do we multiply this by something and get 1? And the shortcut version is you take the fraction and you flip it. So this is a fraction, negative 9, you put it over 1. So you just flip it over. You can put the negative out front. It has to stay with it, and it's just 1 over 9. This is a fraction as well. It's 2y over 1, so flip it over. It's 1 over 2y. So the reciprocal is just flipping the fraction. This is e over 1. Flip it over. It's 1 over e. Now 0 is one of those special cases. You can put it over 1, but when you flip it over and you do 1 over 0, you cannot divide by 0. So there is no reciprocal to this one. And 28, 1 over 6, flip it over. It's 6 over 1, which we don't write a denominator of 1. We just write a whole number 6. And we didn't have to do these, so we are all set.